Working with quadratic functions, an introduction. Did you ever wonder how bridges were designed? What about the Eiffel Tower? These are examples of where mathematical modeling can be used in the real world to design and build structures we use every day. This man-made bridge uses the parabolic design of a quadratic function. This skate park design was also built modeling the parabolic shape of a quadratic. The Eiffel Tower has incorporated the parabola as part of its shape at the bottom. Perhaps the basis of the quadratic function, or the origin of the quadratic function, began as one of our historical mathematician forefathers observed a natural parabola, a rainbow. Let's take a closer look at the quadratic function. There are 4 ways that a quadratic function can be represented. Graphically, we could call this visually, the equation, which is algebraically, the table of values, which is numerically, and of course words, which are verbally. Now, let's start by looking at the graphical representation of a quadratic function. Here are 2 graphical representations of a graphic function. 1, it's opening up. 2, it's opening down. The graphical representation shows the key points of a quadratic parabola for a given equation. The vertex, in this diagram, the vertex is the lowest point of the graph and is called the minimum point. It's the lowest point on the graph. The y-intercept is the point where the graph crosses the y-axis. The x-intercept are the points, notice there are 2, where the graph crosses the x-axis. Note, as I have said, that there are 2 x-intercept values. The axis of symmetry. The axis of symmetry is the vertical line shown by a dotted green line in our diagram that divides or cuts the parabola into 2 symmetrical or equal shapes. This line passes through the vertex. In this graphical representation, we have the same key points, the only difference, the graph now opens downward. The vertex will be positioned at the top of the parabola and so becomes the maximum value of the vertex. Notice we have the y-intercept, we have 2 x-intercepts, and we also still have the axis of symmetry. How to find the key points for a graphic representation. Let's fill in this table with the key values from the graph. We have the name and the value. Let's start by finding the value of the vertex. We can count over 5 and down 3. We know the coordinate is 5, -3. There are 2 x-intercepts, one found at 2, 0. The second found at 8, 0. The y-intercept is at 0, 5. The axis of symmetry cutting through the vertex has a value of x equal 5. Now, let's find the key points for this parabolic shape. The vertex now becomes the maximum point. It's at 5, 12. The x-intercepts are at -2, 0, and 12, 0. The y-intercept is at 0, 6, and the axis of symmetry we can find at x equal to 5. How do you use quadratics?